Now it is time to do some complex heavy duty projects. In this particular project, we'll be doing three different levels of analysis and we'll be using the same flight transportation data. The first one is layover analysis, and the requirement here is that we'll have to identify all possible connecting flights for individual passengers. For each connection, meaning for each connected flights, we'll have to calculate the layover duration and we'll have to flag the connections that are either too short, which are less than 60 minutes, or excessively long, which are more than 6 hours. And we'll have to do the calculation for only one layover. I'll tell you what this layover is in the next slide. The second project or the second sub project or the second analysis is travel activity analysis. Now in this analysis, for each passengers, we'll have to identify the time gap in days between their consecutive flights. The purpose of this analysis is to understand the typical travel frequency, identify the long periods of inactivity, which might indicate potential churns or customer churns, customers who are trying to go away, or to detect unusually rapid sequence of flights. This might be needed for state government or central government or for the airliner. The final analysis is for environmental impact. And what it says is that as environmental regulations become stricter for global warming, there's an increasing pressure to accurately measure and report the carbon footprint of the flights. So you'll need an automated auditable system to precisely calculate the carbon emissions per flight, per aircraft, per route, and per passenger. So you'll have to adhere to the international reporting standards to demonstrate the commitment to sustainability and avoid potential penalties. As you might already know that there are carbon penalties throughout the globe because of global warming. So that's why you are doing this environmental analysis. And for this analysis, we'll need an external data source, which is the CO2 emission standard. So it will have a separate data set for CO2 emission also. I will do the first project, which is layover analysis, and the remaining two, which is travel activity and environmental impact, have to be done by you. So let's talk about a layover analysis and what does it mean. Let's say there's a customer or there's a passenger who wants to travel to a long distance, maybe from one country to another country. And more often than not, you'll be using more than one flights. So what this layover analysis tells you, what is the time duration between those two flights? How much the passenger has to wait? So let's say this is my first flight and the departure time is 10:43 a.m. The first flight starts from the source at 10:43 a.m. and it arrives in the destination at 12:50 p.m. So the total travel time is approximately 2 hours. Then let's say there's a second flight whose departure time is 4 p.m. After the second flight, the passenger would reach its final destination. So what is the layover time here? The layover time is this one, which is the difference between the arrival time of the first flight and the departure time of the second flight. We'll have to find out the layover time and we'll have to see what the duration of that layover is. So if the duration is less than 60 minutes, it means that there might be situations where the passenger has to hurry a lot and there can be potential scenarios of missing the second flight. And if the layover time is very high, more than 6 hours, which means that the passenger has to wait a lot, resulting in bad customer experience. So the airlines want to do this layover analysis to better the customer experience. So these are the considerations they'll have to keep in mind while doing the analysis. The first one is that we'll have to make sure that the flights have to be consecutive and on the same day for layover. That's why in the requirement it mentions that consider only one layover, and there can be duplicate rows in the data and the duplicate rows have to be removed. Why there can be duplicate rows in the data? Because I generated the data using my own script. So there might be scenarios that there are flights for a particular passenger which are duplicate. So we'll have to remove those. And it's not only because of my data generation, there can be scenarios wherein the flight data itself is not correct. So in those cases, we might have to remove duplicate also. So this is essentially data cleansing, wherein we'll have to remove the duplicate rows and then do the analysis. Then we'll have to make sure that the flight data is sorted on departure time. Why? Because if you have to capture the arrival time, departure time between two flights, and if you have to calculate the difference between the two, we'll have to make sure that those are sorted. And as per the requirement, only one layover is relevant. So the arrival time of the first flight and the departure time of the second flight have to be compared. This is a very important consideration, because if you have to do some comparison, you'll have to make sure that the column values are in the same row. So difference of arrival time and departure time is needed for analysis. So this particular consideration is very important, because all the records that we have, those are in different rows. So the first flight journey would be maybe row number 1, then the second flight journey would be row number 2. And we cannot compare between two consecutive rows. As we have to find the difference of arrival time and departure time, we'll have to make sure that those consecutive rows are merged in the same row for a particular passenger. And after this is done, we'll have to flag the layover whose duration is less than 1 hour and more than 6 hours. So this is how the requirement is. Now I'll do the coding for this, and I'll do live coding. And there can be a lot of problems while I do the coding. You have to make sure that after every step you use df.show to see whether the output is making sense as per the business requirement. So whether the output is relevant for the business statement or not. So likewise, you'll have to do the other analysis. Here what I have done is that I have broken down a single line of requirement into multiple considerations. These are not related to Spark, these are related to logic. So how do you implement the logic using Spark? In most of the real life scenarios, you'll find requirements like this. It would not be the case that you join these two data frames, you subtract these two data frames, or find out the year of this data frame. It would not be like that. You'll be given a business statement and you'll have to implement that business statement using Spark. And for that, you'll have to note down the steps that you have to do. And here in this particular slide, that's what I have done. I have noted down the steps, the high level steps that have to be done to complete the layover analysis. And once we start the coding, we'll see what transformation would be needed, what action would be needed. Do we have to join or not? Do we have to use any Spark functions or the transformations that we have spoken or talked about so far? Now, most of the analysis would be done by all the transformations that we have mentioned or that we have discussed in our entire series so far. All right, so let's go to PyCharm and complete the coding for layover analysis. Okay, let's do this. The name of the application that I have kept is 4.1 layover analysis underscore test. The reason I have kept it as test because we'll be testing multiple times, and once I write the entire code, then we'll name it as underscore final. The first thing is that I have selected the passenger name, travel date, departure time, arrival time, and airplane model. And I have used date format because departure time, as you already know, if I do not use date format, it will add today's date in the output, which you do not want. So let's look at the output first. Passenger name, travel date, departure time, arrival time, and airplane model. I don't think airplane model would be needed, but still, I thought let me put it or let me pull it at the beginning of the execution. Later on, we'll change it. Passenger name, travel date, departure, arrival time, and airplane model. So far, so good. First, what I have to do is that I'll have to find out the same day travel, meaning that the travel date should be same for the passenger. For each passenger, the travel date should be same. And then we'll have to order based on departure time. Because the layover can happen only on the same day, we cannot have multiple day layovers because we are doing analysis based on number of hours, not number of days. So let's find that out. And to find the same day travel date, what I think I should do is I'll be using df2 and maybe use a flag called same day underscore flag, and I'll use window function here based on the travel date, right? So if the travel date is same, then the ranking should also be same. In that case, I should use dense rank. Okay, and then over, let me use it, write it in a different row. Okay, so after that it is over, I'll have to use the window function. I have imported window function already. So window partition by, and then you'll have to mention order by. Now let's see what do we have to mention in partition by and order by. Partition by should be based on passenger name, I guess, and order by should be travel date. Okay, so now let's look at the output, what happens. Okay, here is the output, and as you can see, this is 1, this is 2, and 1 2 3 4. So you should get the records where the same day flag has the same number. Now in this case, this is a different date, this is a different date, which will not work. Okay, we have only 20 rows. Let's increase the number of rows and see whether we find the same number in the same day flag. And it should be for the same passenger, and I do not see any same day flag for the same passenger. So what am I trying to do? Let me tell you why have I done this, why have I put the same day flag. If the travel date is same for the same passenger, then the same day flag would also be same, the rank would also be same, meaning that if let's say this passenger Aage something, if the travel date is same for both of them, then this flag would be also same, meaning that let's say there is one more record with travel date 2022-05-18, then there would be two ones for the same passenger, not 1 1, there would be two ones. Now if there are two ones, then it means that this is the same day, these two records belong to the same date, because we are sorting based on travel date, or we are ordering based on travel date. Right now I do not see any record as such, maybe because of the dataset. But what will I do is that let's try to find out whether there are any duplicates or not. In that way, we'll be able to find out the same day record. So what will I do? I'll do a group by, and the group by has to be based on passenger name and travel date both, because you want to find the count of same day flag which is more than 1. Okay, so and now here I'll be using the aggregate function, and inside of aggregate function I'll use count star, or I can mention the column name also, count same day flag, and let's name it as duplicate a row flag. And this duplicate row flag will actually tell us whether there are passengers with the same day or not, and I'll try to increase the number of records maybe. Now what should be the output? The output should be all the rows, the passenger date, travel date, and it would be aggregated by passenger date and travel date. And as you can see, there is one count which is Milan Lukacs, which has this particular count which is more than 2. So there are a lot of customers actually, a lot of passengers actually, which has more than one count. Now we know that this particular passenger, Zlatica Toth, has same day travel, because the travel date is same and count is 2. So right now what will I do? I'll filter out all the records from df4 where duplicate row flag is equal to 2. I do not want 3 or greater than equal to 2. Duplicate row flag is less than 3. There might be rows which has value 3. I do not want that, because the requirement says that only one layover should be okay. We do not need multiple layovers. Alright, so let's do a show of df5, and I think the executor is already facing some memory pressure because of so many executions, so many group bys, so many joinings. We have partition by also here, a shuffle happening here, there's some ordering, then we have group by, then another aggregation. Okay, it says cannot resolve this due to the data type mismatch. Again, some syntactical error. So I put the condition inside of a bracket. I have put both the conditions inside of individual brackets or parentheses. Let's see what happens now. Okay, it looks like there is some memory pressure. It is trying to call spill, but it is not needed. Actually, some memory pressure is building, but we get this records, right? So all these are same day travel. So as we have got the same day travel, now what will I do is that I will join this particular data frame, which is df5, with df2. If I join these two, df5 and df2, then I'll only get the passengers with the same day travel. Of course, I'll have to join with passenger name and travel date. So let's do that. df6 equal to df5, and I'll be joining with df2. And the join condition will be df2 dot passenger name equal to df5 dot passenger name, and df2 dot travel date equal to df5 dot travel date. Of course, I'll have to use parentheses here. So now let's do a show of df6. 20 records should be enough now. And what I should get is only those rows which has same day travel. So all these transformations that we have used, these are to find out the same day travel. So what I had done, just to do a recap, first let's look at the output before doing the recap. Actually, there has been some memory pressure, but we are able to get the output. So as you can see, this particular passenger Aaron Alonso, the travel date is 8/8/23 and 8/8/23, but the departure time is different for both of them. The first one is 58 hours and the arrival time is this, and the second one is departure time is different, right? So it looks like it is working, but of course what we have to do is that we'll have to drop the sum of the columns, and let's drop duplicate row flag. So these are the columns that we do not need. We do not need duplicate row flag because the purpose is done. The second passenger name is not needed because these are repetitive. Same is the case with second travel date, and airplane model is something that we do not need at all. Now let's execute this again. I think we should have a clean data now. So now we have this passenger name, travel date, departure time, and arrival time. And both of these are the same day travel. That's what we wanted, right? Because now I can calculate the layover. What would be the layover? The difference between the first arrival time and the second departure time. So that would be the layover for Aaron Alonso. For the second one, Aaron Castillo, the layover duration would be the first arrival time and the second, oh sorry, this is the first arrival time it seems, and this is the second departure time. So now what will I do is, we'll have to bring them in the same row. The first arrival time, the first departure time, and the second arrival time and the second departure time. These two have to be in the same row. And let's do one thing here. Let's persist df2 also, because df2 is getting used multiple times, right? And I'll persist it in disk. I think storage level got imported. Yes. Okay, so now let's separate these two first. df7.1, and this should be the first arrival date. But how do you do that? We can do one thing. We can actually sort based on departure time for a particular date, and it would be ranked again. So the earlier departure time would be rank 1 and the second departure time would be rank 2. So what we can do is that let's rank based on departure time now, and rank 1 would be the first arrival and rank 2 would be the second arrival. Let's try to do that. And I'll have to use dense rank again over window.partition by and order by. So I'll have to think what should be the partition by and what should be the order by. Order by would be departure time for sure, because we want to rank based on the departure time. And now if I do a partition by can be based on passenger name and travel date. I guess it's okay. If it is wrong, we'll fix it again. All right, so now let's do a df7 dot show, and for each passenger there should be two ranks. And let's see if we can drop airplane model. I hope there's no memory error. Okay, the output is as expected. This is the first travel and this is the second travel. So this departure rank actually is telling us that this is the first travel of this passenger and this is the second travel. Okay, now what am I going to do? I'll be using two different filters. For the first filter, I'll select only the rows where departure rank equal to 1, and I'll rename the column departure time to first departure time, and also I'll rename the column arrival time to first arrival time. And the same thing should happen for another data frame, maybe df8 2, and it should be equal to rank 2 with second departure time and second arrival time. And let's see if you can optimize a few things or not. df2 was getting used multiple times. This is one, this is another one, and df4 is getting used only once, same as df3, but df7 is getting used multiple times, so there should be some persistence. And now what we should do is that we should join df81 and df82 on passenger name and travel date. Okay, so this is how it should be. Let's look at df9 first, just to understand whether our analysis is correct or not, whether the output is correct or not. So now what would happen if I join these two, right? If df81 and df82 are joined, this first arrival time, the first departure time, everything would come in a single row. So earlier these were on two different rows, now it would come in a single row. After getting them in the single row, we can do the layover duration calculation, because we cannot do the calculation on consecutive rows, right? So if you have to do, let's say, subtraction, addition of multiple column values, we'll have to put them in the same row. But in this case, these were two different rows, so that's why I have put them in a same row. And now if there is no memory error, the output should be as per the expectation. Okay, so as you can see, passenger name, travel date, this is a single travel date, this is the first departure time and the first arrival time, this is the second departure time and second arrival time. So the output is correct, and I can drop this passenger name, the second travel date, and also the department rank, or sorry, departure rank. So let's drop these. Now I think the output would be as per our expectation, and after this we can calculate the layover duration. So thus far what I have tried to do is that I have tried to bring the consecutive rows into a single column, so converting multiple rows to a single column. Of course we do not have multiple rows, we have only two rows here because we wanted to do the calculation for only one layover. If it is multiple layover, obviously the entire process would be much more complicated. We'll have to create a few more ranks. We'll have to include the values with count 3 also, or 4 also, depending on how many layovers are wanted. Of course, that would depend on the same day. So if the same day travel is not more than 2, then we are fine. If it is more than 2, then the calculation would be little different, which we do not want to do right now. Okay, so this is the first departure time, first arrival time, passenger name, travel date, second departure time and second arrival time. We are fine. The ordering is not correct. We'll fix this. So now what we'll have to do is that we'll have to convert this first arrival time and the second departure time to Unix timestamp, and then we can calculate the layover duration, because we'll have to do some subtraction, right? Okay, so let's do that. df9 dot with column, and this is the first arrival time, and I'll add one more with column departure time second, because we do not need anything else, right? So we just need the first arrival time and second departure time, because we want to find the difference between the two. Let's see whether it works or not. I'm not sure whether it will work or not, because the departure times are only in time and this expects the time to be in timestamp. Let's see whether Spark converts it to today's execution date. In that case we should be okay, or else we'll have to change the code a little bit. Looks like it did not work, because for Unix timestamp to work, we'll have to have the date or the time in timestamp format. So I think that can be changed. I had done this formatting, right? We do not have to do this formatting as such. So if I do not do the formatting, then it would be in correct timestamp. Let's see again. All right, now it worked. Obviously it is showing the departure time with the timestamp also, which is fine. and this is the first arrival time second and second arrival time, departure time second. Now what we'll have to do is that we'll have to subtract first arrival time second from second departure time second. So in that case, it will give me the layover duration. So let's go ahead and do that, and then we'll do the formatting. So as you can see, we are creating a lot of data frames, and typically this is how it would happen, right? So this is how complex your production workload would be and production deployment would be, or use cases would be. This is not as complex. Of course, this is a complex problem to solve, but this is not as complex. You can get a lot more complex problems also. Anyway, so let's find out the layover duration, and it would be in seconds. We'll have to use expr because we are subtracting these two values, and then we will drop these two values because I don't think we need this. And let's do a df11.show after this. Okay, it says that unsupported operand types for minus. So this is string, it seems. Okay, I think we cannot use expression here. Let's do this directly. Okay, so df9, I do not need expression here. Instead of expression, I'll use Unix timestamp here directly. The problem was because of expression, if I'm not wrong. And same thing would be here as well, minus Unix timestamp, and I'll have to use column function here. Let's try this out. And this should be df10 actually, and this should be df10 as well. Okay, the problem is columnar function with parameter name second cannot be resolved. Sorry, my bad. This should not be second departure time second, it should be second departure time, and this should be first arrival time because I have removed that, right? That's why it is giving error. Let me put it in a different line. Okay, let's see now. It's okay if you are getting too many errors because this is how it should happen, right? You will not get it right in the first place for such complex data frame operations. Now, if you see, the number of data frames that you have created is almost 11 or 12, and you also have used a lot of functions and a lot of operations that you have learned so far. So of course it is not possible to get it right in the first place, and what I would recommend is that you try it out yourself, then you look at this particular code. So it worked this time, first arrival first departure, and it is also giving the layover duration. So I think we are at the final leg. What will you do is that we'll select from df10 and we'll select first passenger name, then travel date, then first arrival time now should be formatted to hour, minute and second. Same should be a second departure time also, and now let's use expr. We could have used when otherwise also, but I'm choosing to use expr. I'll be using the when statement. So when layover duration second is less than 60, then okay, this is what it is. Of course, I'll have to use the case statement, my bad, and end, and I'll use it with column because I need a layover comment column. Seems like there is some syntax error. Let me remove this. Okay, now it's fine. So what am I doing? I'm getting the passenger name first, then the travel date, and the first arrival time in hour, minute, second. The second departure time is also in hour, minute, second, and layover comment. And I'll have to add a few more date formats also. So this is how it should be, and I can write it to a file, or let's do a show. If the output is correct without error, then we'll do an analysis in the Spark UI as well. So it should not be otherwise, it should be else here. It's giving error again that layover duration second cannot be resolved. Oh, sorry, I'll have to select the layover duration here also, because what am I doing is that there's a chain transformation, right? So definitely I'll have to select layover duration here. That's why it is giving error. So it is layover duration second. Now I think it should work, and I could mention otherwise here also. Okay, it is working now. Obviously the format is not correct. We'll have to alias it. And we have this layover comment also. So this is how we solve it. Let me name it as underscore final so that we can take a look at the Spark UI also. So let's see what is happening, how complex the DAG is. Let me repeat what I have done. First, I have selected the columns, passenger name, travel date, departure time, and arrival time. Now, earlier I converted this departure time to only hour, minute, second. Same I had done for arrival time also, but that could not be done because we have this Unix timestamp that we have to use at the end, and Unix underscore timestamp will not work unless it is in timestamp format or in date format. So that's why I did not convert it. Airplane model is something that I did not need at all. After that, we have this with column. So here what I'm doing, I'm creating a column named same day flag, and I'm ranking with travel date in the order by, and I'm partitioning by passenger name. Why am I doing this? Because if the travel date is same for both the records, then the rank would be same. So let's say the first travel date is 1st January 2025, the second travel date is 2nd January 2025, the third one is 3rd January 2025, and the fourth one is 3rd January 2025. So the rank would be 1, 2, 3, and 3, and that's what we want. So after that, I am aggregating that count, the same day flag, which is 3 and 3 that I just told you, and it would be a duplicate row flag, and we want the duplicate row flag. That's why I am filtering it out wherever the duplicate row flag is greater than equal to 2 and less than 3. Why this is the case? Because we want only one layover. If there are more than 2 layover that you have to analyze, then of course this duplicate row flag would be different, and also that same day flag would be different, because if these are on multiple days, then we might have to look at the itinerary number to find out whether they are from the same travel or not. Anyway, we have not complicated the use case as such. Now after this, what I have done, now here I'm joining this output, this df5 with the df2. And why am I doing this? Because in this case, we can find out all the columns for the layover. And after that, I'm using again dense rank based on departure time. And in this 8.1 and 8.2, I'm converting consecutive rows to a single row. So I'm converting 2 rows to a single row. And after that, it becomes pretty straightforward. I'm just converting the second departure time to seconds using Unix timestamp, and the first arrival time to seconds using Unix timestamp. Then I'm subtracting, and then here I'm using this expr function to comment it out. Okay, so this is how it has been, and let's execute this one final time, and then we'll take a look at the Spark UI. Sorry, I'll have to mention else here. Now let's execute. So now it is working. Let's look at Spark UI. Okay, this is the final because the first final actually failed because of syntax error. Now let's open this, and there are so many jobs, right? So there are so many show strings. It's better that I write it to a file. Then I think it would be easier to look at how the DAG is. Here also we have multiple saves, it seems. So let's look at SQL data frame tab. We have load and save, and I am guessing that it would be pretty complex, and as of course it is a pretty complex one, I'll reduce the size to see how big is the DAG. So this is how the DAG is. So as you can see, we'll have to analyze this DAG to see whether there is any problem or not. Now what is happening, there's a scan, there's a whole stage code gen in-memory table scan because we have saved in disk. Then we have again whole stage code gen where we have filter and hash aggregate. I'll talk about hash aggregate in the next section. And here we have exchange. In between, there's another parallel processing which has started, that is scan. Then you have WSCG of project. And here after the exchange, there are 2 WSCG, 2 hash aggregate, and 2 filter. Now inside of this whole stage code gen, we have hash aggregate, filter, project, and sort. And here also there's an exchange. In whole stage code gen you have sort, then you have sort merge join, which we'll talk shortly in the next section, then project, sort, etc., and so on and so forth. So do you look at this entire DAG one by one to find out if there is any problem? The answer is of course no. What we should typically do is, whenever there's a performance problem, we'll look at which stage or which job executed or took the most time, and then we'll go deeper into that particular job, which I'll show you anyway in the performance tuning exercise. And these are the stages. There are multiple stages, multiple shuffle writes, the shuffle read also, etc. And in the executors, there is only one executor, it seems, and 1066 tasks got completed. Total time was 52 seconds, and the GC time is 2 seconds, which is less. Input is 27.3 GB and the output is 3.01 GB. Let's select all the metrics and look at the JVM usage. This is the peak execution memory usage. Peak is 730 MB. Then storage memory usage was 571 KB, peak pool memory, etc. So then we have shuffle read, shuffle write also. So this is something that you already know how to read. And the reason you see only one driver, because I had stopped the worker instance that we were using earlier. That's why we are seeing only one driver here, or one executor rather. So the first sub project is done, which is layover analysis, and I expect you to complete travel activity and environmental impact. Not only that, for layover analysis also, do not look at the code initially. Try it out yourself and then only look at the code. Same would be the case with travel activity and environmental impact. Anyway, I do not have the codes written for the second and third use case. You'll have to create the code or write the code and execute it. That's all about this particular section. Thanks for watching.